Next we are going to see some theorems, that is results. The pole of Lx plus My plus n equal to 0 with respect to the circle x square plus y square equal to r square is minus r square L by n comma minus r square m by n. So given circle is x square plus y square equal to r square, that is equation number 1. Let p x1 y1 be the pole of Lx plus My plus n equal to 0 with respect to 1. That is Lx plus My plus n equal to 0, that is equation number 2, is the polar of p x1 y1 with respect to 1. Because p x1 y1 is the pole of Lx plus My plus n equal to 0, that means Lx plus My plus n equal to 0 is the polar of p x1 y1, right? So we know that the polar of p x1 y1 with respect to x square plus y square equal to r square is x x1 plus y y1 minus r square equal to 0, right? So that is equation number 3. So equation 2 and 3 represent the same line, that is polar. So comparing 2 and 3, so coefficient of x in 3 is x1, in 2 is L, x1 by L, which is equal to coefficient of y in 3 is y1 and in 2 is m, y1 by m, which is equal to constant term in 3 is minus r square, in 2 is n. Now we are going to consider the first and third. X1 by L is equal to minus r square by n. Therefore x1 is equal to minus r square L by n. Similarly you consider the second and third, right? Y1 by m is equal to minus r square by n. Therefore y1 equal to minus m r square by n. Therefore the pole with respect to pole of Lx plus My plus n equal to 0 with respect to the circle 1 is minus r square L by n comma minus r square m by n. Next theorem result, the pole of Lx plus My plus n equal to 0 with respect to the circle general form. In the previous case it is the circle passes through the origin, right, with radius r. Here the circle is the general form, right? X square plus y square plus 2gx plus 2fy plus c equal to 0 is minus g plus r square L by L g plus mf minus n comma minus f plus r square m by L g plus mf minus n. R is the radius of the circle and Lx plus mf minus n, Lg plus mf minus n not equal to 0. If it is 0 then it will not exist because it is in the denominator, that is why, right? So we will see the proof. Given circle is general form x square plus y square plus 2gx plus 2fy plus c equal to 0, that is equation number 1. Let p x1 y1 be the pole of Lx plus My plus n equal to 0 with respect to 1. So Lx plus My plus n equal to 0 is the polar of p x1 y1 with respect to 1, that is equation number 2. We know polar of p x1 y1 with respect to the circle general form, not this one, with respect to 1, not x square plus y square equal to r square, x square plus y square plus 2gx plus 2fy plus c equal to 0 is x x1 plus y y1 plus gx plus x1 plus f y1 y plus y1 plus c equal to 0. So rearranging x x1 plus y y1 plus gx plus gx1 plus fy plus fy1 plus c equal to 0. So grouping x term, y term and constant term, x into x1 plus g plus y into y1 plus f plus gx1 plus fy1 plus c equal to 0, that is equation number 3. So equation 2 and 3 represent the same equation, that is polar. So comparing 2 and 3, so that is coefficient of x, y and constant term. So from 3 coefficient of x is x1 plus g, from 2 coefficient of x is L, x1 plus g by L, which is equal to coefficient of y in 3 is y1 plus f, in 2 m, so y1 plus f by m. Then constant term in 3 is gx1 plus fy1 plus c, and in 2 is n, so gx1 plus fy1 plus c divided by n. Now that is x1 plus g by L, which is equal to y1 plus f by m, which is equal to gx1 plus fy1 plus c by n, which is equal to gx1 plus g plus fy1 plus f minus gx1 minus gx1 plus fy1 plus C divided by Lg plus Mf minus N. So we are using property of ratio. So take the first one, multiply numerator and denominator by G. So first one is x1 plus G by L, right? The ratio, right? There are three equalities, right? So taking the first one, x1 plus G by L. So multiplying numerator with G and denominator with G. So G x1 plus G by GL. Take the second one, multiply with F. F y1 plus F by Fm, right? Then last take the third one. So adding all numerator and all denominator, all are equal, right? This is the property from the ratio, right? Ratio and proportion, right? So that is why we will get this one, right? Now that is equal to multiplying with gx1 plus g square plus fy1 plus f square minus gx1 minus fy1 minus c by lg plus mf minus n. So here gx1 minus gx1, fy1 minus fy1 get cancelled. So remaining you will get g square plus f square minus c by lg plus mf minus n. We know radius of the circle 1 is r is equal to root of g square plus f square minus c. So you will g square plus f square minus c is nothing but r square, right? Instead of r you can put r square. So r square by lg plus mf minus n. So consider first ratio and this one, right? All are equal, right? x1 plus g by L, which is equal to r square by lg plus mf minus n. So therefore x1 equal to minus g plus L r square by lg plus mf minus n. Similarly, considering second and the last one, right? Last one means r square by lg plus mf minus n. So all ratios are equal, right? So first, second, third, fourth, fifth, sixth, seventh, all are equal, right? So we are taking second one and last one. y1 plus f by m, which is equal to r square by lg plus mf minus n. Therefore y1 equal to minus f plus m r square by lg plus mf minus n. Therefore the pole is minus g plus r square L by lg plus mf minus n, comma minus f plus r square m by lg plus mf minus n. Thanks.